Hello everyone, I am Ans, welcoming you all to this channel Aaru Underway, your voyage to marine mastery. About Aaru Underway. This channel focus on IMU syllabus revised for 2026 batch, also applicable for 2024 batch, 2025 batch, 2027 batch and all the upcoming batch in the syllabus is same. This channel provides a detailed maritime subject like navigation, engineering and seamanship. You will also get real sea life experiences and career tips. This channel helps the aspiring mariners to build a strong foundation. Today we will study the subject fluid mechanics, Unit 1 fluid property and its measurement. Unit 1 fluid property and its measurement. Your journey to maritime excellence begins here. In Unit 1 we will study these 12 topics in today's lecture, and in last we will solve MCQ and some PYQ. First we will start with definition of fluid pressure, then we will study the physical meaning of pressure, then we will know about why does a fluid exert pressure, then property of fluid pressure, then factor affecting fluid pressure, SI unit of pressure, dimension, formula of pressure, examples, application in marine engineering, important formula, Pascal's law and its derivation, that is very important. And in last we will know about absolute, gauge, atmospheric and the vacuum pressure. So first we will start with definition of pressure. So basically the pressure is the normal force exerted by a fluid per unit area on any surface in contact with it. It means that let's suppose that this is a beaker and water is filled inside the beaker, and on a unit area how much force is applied is known as pressure. It means like E equal to force upon area, that on a unit area how much force is applied normally is known as pressure. In definition we can write that the normal force exerted by a fluid per unit area on any surface in contact with it. Formula, you can write formula P equal to force upon area, where P is pressure, its unit is Newton per meter square, F equal to force, or you can say force acting normally, its unit is Newton, and A is area and its unit is meter square. In examination you can write the definition of pressure, then write this formula and also mention this and draw this diagram. You will get full marks. That is the same picture, and this is the picture for visualizing, like that in a beaker that is filled with water and on a unit area the force is applying, and the force will apply normally to the object on a unit area, and force is same in all directions. And our second topic is physical meaning of pressure. In physical we can understand the pressure, like example, a school bag. the strip of the school bag are thicker because if thicker means the area of that strip is more. If we increase the area, the pressure will reduce. From this equation, we can understand that pressure is directly proportional to force and pressure is inversely proportional to air. If we increase the pressure, force will also increase or vice versa. Or if we decrease the area, pressure will increase, and if we will increase the area, pressure will decrease. You can also take the example of iron nail. If you stand on single nail or two or three nail, the nail will get into your the foot. But if you stand on thousand of nail, the surface area get increased and your body weight will remain same and the pressure will get reduced and you will be easily able to stand on the iron nail without any damage. It means like E equal to force upon area. It means if the force is same, let's suppose in example 1, force is 500 and area is 2 meter square. So the pressure will come out 250 Newton per meter square. And for the same force, if we increase the area, suppose 50 meter, yeah, or let's suppose 5 meter square, it will become 100 Newton per meter square. By increasing the area and remaining the force constant, the pressure will reduce. In simple word, we can say that a large force acting on a small area produces high pressure. A large force acting on a small area. It means area P is equal to force upon area. Let's suppose the force is very high, means like 1000 Newton, and pressure is and area is 2 meter. So it will give 500 Newton per meter square. That is very high. In second statement, we can say that the same force acting on a large area produce low pressure. It means same force acting on large area. It means force is same, but the area become large. Suppose 50 meter square. So it will become 20 Newton per meter square. So by increasing the area and keeping the force same, pressure will reduce. Thus, we can say that pressure depend upon both force and area. Now move to third topic. We will see what why does a fluid exert pressure. The question is that why does a fluid exert pressure? Like in a beaker, if we put some water, the water is exerting the force on beaker outside in this direction. Normally, normal to the direction. The reason behind this is like a fluid exert pressure because its molecules are in continuous random motion. The molecules of water are always in random motion. They are moving from here to there, so they are exerting the pressure on the wall of the beaker. So we can write a fluid exerts pressure because its molecules are in continuous random motion. If we explain the molecular motion, we can write fluid molecules move randomly in every direction. Then the molecules of fluid are moving in every direction. And second, we will write they continuously they continuously collide with each other with container wall, the bottom surface of the beaker, and also any object immersed in the fluid. Our fourth topic is characteristics and property of fluid pressure. In the fourth topic, we will study the property of fluid pressure. So, its first property is fluid pressure act normal to the surface. It means it means the fluid pressure act normal to the surface. It means like the pressure is always act at the 90 degree to any surface inside the fluid. Like it is a beaker outside and the water is filled inside the beaker and there is an object on the surface of the object on the area. The pressure always act at 90 degree, always perpendicular. At any point on surface of the object, the force exerted by fluid is perpendicular, means 90 degree to the surface of the object. So this is the first property of the fluid. In this topic, we can write it. Let me change the color. Like pressure always act perpendicular to the surface. In examination, if they ask for property of fluid, you have to write the heading and this one and also draw this diagram. Important, note this one, like the fluid pressure is always act 90 degrees perpendicular to the surface. It does not act parallel to the surface. Important, it never acts parallel to the surface. You can give the example, water press normally against the wall of a ship blast tank. In the ship, the blast tank is filled with water and the water exerts normal force on the wall of the blast tank. Its next property is fluid pressure act equally on in all directions. It means fluid pressure act equally in all directions. You can understand from this image that a beaker is filled with water and there are three holes. At the same height, means you can say same height or same depth or height, the pressure acting equally from this hole 1, 2, 3. All three, the water is coming out from the same pressure. You can see these all three are identical, or you can say symmetrical. At same depth, the pressure in a liquid are equally in all directions. Or you can also understand from this diagram, there is a beaker filled with water. Here the water is coming out from this hole. Here let the distance is d, and here the distance is also d. So in examination you have to draw this diagram. If you are able to draw this one, you can also draw this one. So in this topic we can write at a given point in a stationary fluid, pressure is same in every direction. And also note that this principle this principle is known as isotropic nature of pressure. This can be asked in MCQ. Isotropic nature of pressure. Application of this property. First is hydraulic press. Hydraulic press. Second is hydraulic jack. And third one is hydraulic steering system. This system is used in onboard ship. Its third property is pressure increase with depth. It means as you increase the height, or you can say depth, the pressure will increase. Pressure increases with depth. You can see from this diagram, like this is a beaker or jar of height h, and this first hole is height h1, the second one is at height h2, and third one is at height h3. And you can see that h3 is more than 2 and h2 is more than 1. So as the height is increased, means as you go in the upper part, means in the above portion, the pressure will decrease, because this hole is getting the pressure of only this much of water, but this hole is getting the pressure of this much of height. So here the water is going far, and similar for the second one, water is going to the medium, and the last one, the water is going and the least. It is the weakest jet, it is the moderate jet, and it is the strongest jet. I will write it clearly, like this height is h1, this height is h2, and this height is h3. Pressure increase with depth. In this topic, we can write as depth increases. From this diagram, we can say that pressure is directly proportional to depth. As we increase the depth, more liquid exit above the point. Therefore, the weight of the liquid increase. You can write the formula for this property. You can write pressure equal to rho g h, or rho, or in some book you find p equal to rho g z. Here z and h are both are depth, or you can say height. Here rho is density, its unit is kg per meter cube. G is acceleration due to gravity. Acceleration due to gravity. Its value is 9.81 meter per second square. And h stands for depth in meter. And this is the important conclusion from this property, that P is directly proportional to depth. Fourth one. The fourth property is that pressure depend upon density. Pressure also depend on density. From this image, you can understand that in the upper image, this is water, and here it is cooking oil. The oil density of oil is less than density of water. So here the jet of water is going far, or you can say jet of liquid is going far in case of water, and jet of liquid is going less in case of cooking oil at the same height, because water is more dense. So water exerts more weight, because you know that pressure is equal to force upon area, and force is ma upon area. Force equal and F equal to ma. So here the mass of water is more. Mass of water is 1 into, suppose area is also 1, and upon area, suppose area is also 1. No, suppose, sorry. Here the sub mass is 1 and acceleration is 9.81 and area is 1, so it will become 9.81. And in case of while P equal to force upon area, here F equal to ma upon area, mass of cooking oil is 0.93 into 9.81 divided by 1. So if we calculate it, we will get, let me calculate this. You will get 9.1233 Newton per meter square. Newton per meter square. So from here you can say, as the density increase, pressure also increases. So in this topic we can write, let me change the color. We can write denser fluid produce higher pressure at same depth. For example, you can give the example of this one, oil and water, or also you can give the example of mercury, that mercury exerts much higher pressure than water, because mercury has a much higher density. The density of mercury is 13.6. Mercury exerts much higher pressure than water, because mercury has a much higher density. So the density of mercury is 13 kg per meter cube, and density of water is 1000 kg per meter cube. So pressure of mercury will be more than pressure of water. And you can draw this diagram in your examination. Now fifth property. Let me change the color. Fifth property is pressure is independent of container shape. Pressure is independent of pressure shape, vessel shape. It means the pressure does not depend upon the shape of any container. It depends on the height, or you can say depth of the container. Like here the water is in all the container is at the same level, and the shape of each container is different, and in this the meter you can see that the pressure is same in all of them, as there is no shape is same, but the pressure is same, because the height, this h, is same in everyone. So pressure is independent of Container shape it depends upon the depth. Pressure is directly proportional to depth. We can also write here in this topic like pressure depends only upon first density, more pressure, gravity, more pressure, and the third one depth, more pressure. Or we can also let me add one slide. Or we can also conclude here that the pressure does not depend upon container shape, कंटेनर विद मतलब कंटेनर के चौड़ाई भी या लंबाई पर भी डिपेंड नहीं करती है कंटेनर के चौड़ाई पर ये it will depend upon the level of water. If the level of water is same in all the container and whatever the shape, the pressure will be same. Third one, volume of liquid. It also does not depend on the volume of liquid. And here, this and this one both are same. This is upright condition and this is inverted. So the volume of water in is suppose Va. So and in this one is also Va. But this is thinner. So volume of water in this is not Va. Let's suppose Vb. And here let's suppose Vc. Here you can simply say that volume of water Va is more than Vb, Vc or Vc is more than Vb. But the pressure is remains same because it does not depend on the volume. It depends upon the height in height or depth. Sixth property is pressure act in every direction. The property 6 said that pressure act in every direction. It means that if a object is submerged inside the water, the pressure will act equally from all directions. Let's suppose this object B is submerged in the water. The pressure P will act in all directions equal in magnitude and also it is at perpendicular distance 90 degree. So we can write that fluid exert pressure in all direction means downward, upward, sideways, and in every possible direction. This is the reason because force is acting in all directions. This is the reason that dams require thick wall near the bottom because at the bottom pressure is maximum. Now comes to topic number 5, which is factor affecting fluid pressure. It is similar to property factors affecting fluid pressure. So the first factor is depth. As the depth is more, pressure is also more. Depth is less, pressure is also less. Second, density. High density, high pressure. High density, high pressure. Third one, gravity. More gravity, more pressure. And pressure is independent of shape of container, quantity of liquid, and third one, surface area of container. Now coming to sixth topic, SI unit of pressure. So basically the SI unit of pressure is Pascal. Pascal, it is denoted by PA. The definition is 1 Pascal is the pressure exerted when a force of 1 Newton acts normally on an area of 1 square meter. It means when the force of 1 Newton is acting on per unit area. Means you know the formula P equal to force upon area. P equal to force upon area. When the force of 1 Newton acting on area 1 meter square is known as 1 Pascal. Newton per meter square. So we can write its definition like 1 Pascal is the pressure exerted when a force of 1 Newton acts normally on an area of 1 square meter. 1 Pascal equal to 1 Newton per meter square. Next is 7. 7 is dimensional formula of pressure. Dimensions of pressure. So basically the formula for pressure is P equal to force upon area. Since force equal to ma, if we write the dimensional formula for the force, m equal to m, a is equal to lt minus 2, because a is acceleration is meter per second square, So for the meter, the symbol become L, and for the second aspect become T square. If we take the T square in numerator, it will become T minus 2. L T raised to minus 2, and for area is meter square. So it is simply L square. So force equal M L T minus 2 and L square. The dimension formula always write in this square bracket. So we can write from here M L minus 1 T minus 2. This is the dimensional formula of pressure. Now at 1 we will see some examples like sharp knife. The suppose this is a knife. This edge of knife is very thin and sharp because as the area as per the formula, area decreases, force increases. Means for the same force, area decreases, so pressure increases because pressure is inversely proportional to A. If A decrease, pressure increases. You can also take the example of ship hulls. The hull experiences water pressure from every direction. Pressure increase as the ship sinks deeper. As the ship go deeper in the sea, the pressure on ship increases. We are taking the all-round example from the pressure. Third one, we can take example of dam construction. We are taking example on properties like here area is reduces, so pressure increases. Ship hull, as ship go deep inside the water, the pressure increases. Depth increase, pressure increases. Dam construction. Dam wall are thick at the bottom because pressure increases with depth. Thick at bottom because depth increases, pressure also increases. Now come to application in marine engineering. Let me change the color. What are the applications in marine engineering? There are some important applications like ballast tanks, hydraulic steering gear, hydraulic cranes, and firefighting pumps, boiler feed system, cargo pump system, cooling water circulation system, Some more is ship stability calculation. These application using ship stability calculation, pressure gauge and manometers. Now let's see some important formula that will be helpful for solving the numerical. So first is pressure formula. Pressure P equal to force upon area. Very simple. Second one is hydrostatic pressure. It is P equal to rho gh, density into acceleration due to gravity into depth. Third one is total pressure. Total pressure is Pt equal to P atm plus rho gh, hydrostatic pressure. The value of P atm means pressure of atmosphere is 101,325 Pascal, or you can write 1.013 into 10 raised to 5 Pascals. Remember some important value like density of water is 1000 kg per meter cube. G equal to acceleration due to gravity 9.81 meter per second square, and H in depth in meters. Let's solve some example on this. So now solving the example number 1. A tank is open to atmosphere. Find the pressure at 5 meter below the water surface. We have to find the total pressure for this. So here the height, or you can say depth, is given 5 meter. So we can use P equal to rho gh. So we can take, if water is given, the density of water is 1000 into 9.81 into height is given 5. We can solve this, so it will come out 490 plus 49050. For finding the total pressure Pt, we have formula P atm plus rho gh, and the value of P atm means atmospheric pressure is 101,325 plus 49050 equal to 150375 pascals, or you can say 150.4 kilopascals. Let's solve the second numerical. In second numerical, a diver is 2 meters below the water surface. Same formula here we will apply. Pt equal to P atm plus rho gh. So P atm is 101,325 plus 1000 into 9.81 into 2. So it will give 19620. After adding, it will become 120945 pascals. Now the topic is Pascal's law. That is very important. The Pascal's law said that the pressure at any point in a fluid at rest is equal in all directions. We have already studied that pressure act equally in all directions normally. Pascal law stated that pressure applied to confined fluid is transmitted equally and undiminished in all directions throughout the fluid, act in right angle normal to the containing surface. Here you can see in the image that a beaker is filled with water and a object is here, and the pressure is acting on it or acting by it equally in all directions, in every direction at 90 degrees. Or here you can say the ram and plunger, that if you are applying force F1 at the smaller area A1, it will transmit equal power, or you can say pressure, in the bigger one F2 A2. So the formula for pressure is P equal to F upon A. So therefore we can say P equal to F1, F upon A by F upon A1 equal to F2 upon A2. Or if we take A2 multiply this side, then it will become F1 into A2 by A1, where F1 is input force, A1 is input area, F2 is output force, A2 is output area, and P is pressure in the fluid. Key takeaway: in a fluid, pressure is same at a given level in all directions and is transmitted equally and undiminished throughout the fluid, acting normally perpendicular to the surface. Next is derivation of Pascal's law, that is very important. We have to prove PA equal to PV equal to PC in Pascal's law. From this diagram we can prove it very easily. Let's suppose in equilibrium condition, the force acting this side is F2, this side is F3, and in the above one acting F1. If we resolve this, it will become F1 is here, F1 cos theta, because theta is here, and this side F1 sin theta. So we can write this like as equation 1, F2 equal to F1 sin theta, because it is F2 is equal to F1 sin theta, and second equation F3 equal to F1 sin theta, F1 cos theta. Now from diagram we can see that here is written B, here is written C, and here is A. So we can, from the diagram we can say that this F1 equal to FA. FA means force area of phase. This A is area of phase. F2 equal to FB and F3 equal to FC. So now here we can write cos theta, and there is a theta. Cos theta is base by hypotenuse. So base is here. We can say C, AC, area of phase C, and upon hypotenuse area of phase A. Cos theta equal to area of phase C and area of phase A. Similarly, and we can write it AC equal to cos theta into area of phase A as equation 3, and similarly we can write for sin theta. Sin theta is perpendicular by hypotenuse, so here we can write that area of phase B upon area of phase A up AB upon A small a, and we can write AB equal to A sin theta, equation 4. Now if we divide 2 divided by 3 and 1 divided by 4, what we will get? We will get FC upon AC equal to FA cos theta upon AA cos theta. The equation 2 is F3 equal to F1 cos theta and F1 equal to Fa. So in place of F1 we can write Fa and cos theta is as it is, and Fc. F3 we can write as Fc. So here Fc, and equation 3 is AC equal to AA cos theta. So we can cancel out cos theta. So what we will get? Since we know that pressure is equal to force upon area. So here it is Fc upon AC. This is PC equal to PA. Now from 1 and 4, what we will get? We will get A small b upon FB equal to, sorry I am writing the wrong. We will get FB upon AB equal to FA sin theta upon A small a sin theta. The sin theta get cancelled, and this will become PB equal to PA. And from here we can write PA equal to PB equal to PC. Hence the Pascal's law get proved. This is very simple. Now we will learn about absolute gauge and atmospheric pressure and vacuum pressure. Here is the diagram from where you can understand. There is two absolute pressure. One is above the atmospheric pressure and one is below the atmospheric pressure. So absolute pressure. The definition said that the total pressure measured relative to a perfect vacuum. Perfect vacuum means zero from here. It includes atmospheric pressure plus gauge pressure. This atmospheric pressure and gauge pressure. It means P absolute equal to P atmospheric plus P gauge. But we can also write it as, for this absolute pressure, like PABS, P absolute. How we can get this one, a smaller one? If we having the atmospheric pressure P atm, we can subtract the P vacuum. So we will get P atmosphere for this smaller one. Gauge pressure. The pressure measured relative to surrounding atmospheric pressure. It is the pressure indicated by most pressure gauge. Pressure gauge equal to P absolute minus P atmospheric pressure. Gauge pressure, it is more than atmospheric pressure. P gauge is more than P atm. Gauge pressure is the difference. Like in ship, you have studied in boiler that the safety valve will lift at the, suppose 10 bar. Suppose safety valve lift at 10 bar, but actually it is 11 bar, because the 1 bar means atmospheric pressure is the reference, that is theta and 0, means 1 bar means atmospheric pressure is relative to 0, that is 0, and when 2 bar of ATM reach the gauge will show the 1 bar. Atmospheric pressure, the pressure exerted by the Earth's atmosphere on all objects at sea level, it is approximately 101.325 kPa or 14.7 psi. We can also write the formula for the PATM. P atmospheric equal to P absolute plus P vacuum. Vacuum pressure, the pressure below atmospheric pressure, it indicates how much pressure is less than atmospheric pressure. The formula for the vacuum pressure is P vacuum equal to P atm minus P absolute. P atmospheric pressure minus absolute pressure. Here you can see all the formula for all types of pressure. Note important. You have to remember these values because this can directly ask in your MCQ. The atmospheric pressure at sea level at 15 degrees Celsius is 101.3 kilonewton meters per or 10.3 Newton per centimeter square in SI unit, and in MKS unit it is 1.033 kgf, means kilogram force per centimeter square. The atmospheric pressure is 760, this is important, mm of mercury, and 10.33 meters in water. One, remember this will help you in numerical. 1 kgf equal to 9.81 Newton. How we will get this? 1 kgf means 1 kg 1 kgf equal to 981,009 in CGS. And how we will get this one? We know that force equal to mg, and the unit of mass is kg, and g acceleration due to gravity 9.81. So we will get it 9.81 newtons. Let's solve the MCQ. Question number 1. Which of the following best describe the vacuum pressure? Pressure that is higher than atmospheric pressure. Pressure measured in relation to perfect volume. The absolute pressure in a system measured from zero pressure. The pressure that is lower than the atmospheric pressure. So the correct option is option number D, because vacuum pressure is the pressure lower than the atmospheric pressure. Question number 2. What does Pascal's law state? Pressure applied to the confined fluid transmitted undiminished in all directions. These all MCQ are very important related to your university examination. All these are PYQ, and all these MCQ can be asked in your examination. The fundamental SI unit of pressure is Newton meter square. This is also known as Pascal. Next is question number 4. The gas are considered incompressible when Mach number. When the Mach number is less than 0.2 Mach, then the gas is considered as it is incompressible. If the Mach number is more than 0.2, it is considered as compressible. Next question. Question number 5. Pascal's law. Pascal's law states that pressure at a point is equal in all directions. In a liquid at rest, in a fluid at rest, in a laminar. ये दोनों तो होंगे ही नहीं. कंफ्यूजन इसमें हो सकता है क्योंकि फ्लूइड जो होता है गैस और लिक्विड दोनों होता है, और जो लिक्विड हुआ वो सिर्फ लिक्विड हुआ. तो इसका करेक्ट जवाब होगा फ्लूइड, बिकॉज हम लोग पास्कल्स लॉ में कोई पार्टिकुलर लिक्विड के बारे में नहीं पढ़ते हैं, हम लोग उसमें फ्लूइड के बारे में पढ़ रहे हैं, मतलब कि वी आर स्टडिंग आउट बोथ गैस एंड लिक्विड. What is Pascal's law? We have already discussed. So we can write the definition of Pascal's law. It is also the PYQ question. Pascal's law, so we can write that the intensity of pressure at a point in a fluid at rest is same in all directions. Is the same in all directions. Next question, question number 7. The hydrostatic law states that the rate of increase of pressure in a vertical direction is equal to density of the fluid, a specific weight of the fluid, and none of the above. The correct answer will be a specific weight of the fluid. A specific weight means mass density, means W. Mass upon means weight upon volume. weight upon volume. It does not depend on the density, it depends upon the weight upon the volume. Because you know that hydrostatic law P equal to rho gh. There is also g, acceleration due to gravity. Next question is question number 8. Fluid statics deal with viscous and pressure force, viscous and gravity force, gravity and pressure force, surface tension and gravity force. So it will deal with gravity and pressure force. Option number C. Question number 9. Gauge pressure at a point is equal to gauge pressure. Remember the graph. Gauge pressure is more than the atmospheric pressure. This is gauge pressure. Absolute pressure plus atmospheric pressure means absolute plus ATM. Absolute pressure means this one minus atmospheric pressure. Vacuum pressure plus absolute pressure. Vacuum pressure means this one plus absolute pressure, this one plus absolute pressure. So the correct option is option B. Absolute pressure means this whole one minus atmospheric pressure. You will get the gauge pressure. Or you can also go to this slide. Gauge pressure is absolute pressure minus atmospheric pressure. Here gauge pressure is absolute pressure minus this atmospheric pressure. This one you will get the gauge pressure. Question number 10. Gauge pressure at a point is equal to gauge pressure point. Both are same question. So the option B is correct. Question number 11. Atmospheric pressure held in terms of water column is 10.33 here 3.0 given, but it is 10.33 meter. Both are correct. Thank you so much for sailing with us at Aaru Underway. If you have any problem, comment in the comment section. Your journey to mastering marine engineering has just begun. Subscribe, stay curious, and keep moving forward. Thank you for watching the video.